This is the Investigation 1 handout, Understand Rules of Exponents, Investigation 1. The first question asks, which of the following expressions are equivalent to 2 to the power of 3 times 2 to the power of 5? And remember to select all that apply. So the first one here is a 2 times 8. So this you could get from, if we separate this out as I did up here, 2 to the power of 3 is equal to 2 times 2 times 2, and 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. To multiply these together, we then get 2 times 2 times 2, this part, times 2 times 2 times 2 times 2 times 2, which is this. So that is 8 2's, so this is equivalent to 2 to the power of 8. So in this scenario, instead of multiplying 2 by itself 8 times, they're multiplying 2 times 8, which is incorrect. B is 2 times 15, and they probably got that by multiplying the 3 and the 5 together to get 15, but that is not correct. That is not how exponents are solved. C is exactly what I showed you up here with 2 multiplied by itself 8 times, and that is correct. D is 2 times 2 times 3 times 5, and that was probably gotten by 2 the base times 2 the base times 3 the exponent times 5 the exponent. That is not true. That is not how exponents are solved. Exponent means the base number multiplied by itself however many times the exponent states. E is 2 times 3 plus 2 times 5. There's two major things wrong with this. Once again, instead of multiplying 2 by itself 3 times, they tried to multiply 2 times 3, and they added the two quantities together, which, when there's no sign in between, this implies multiplication. F is 2 times 5 plus 3, and that was probably gotten by 2 and then times 3 plus 5. This would be okay if it was 2 to the power of 5 plus 3, because that's 2 to the power of 8, and that's actually how you can solve for it. For example, if we have x to the power of L times x to the power of j, the exponent would be equal to x to the power of L plus j, but this was done incorrectly, so it does not work. And here, this is 2 times 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 2, which is exactly what I showed you up here by multiplying the first value times the second value, so this is correct. H here did the same thing over here, except instead of multiplying these two together, it adds the 2, which is once again incorrect because these 3 2's come from 2 multiplied by itself 3 times, and these 5 2's come from 2 multiplied by itself 5 times. However, once again, since there's no value in between, multiplication is implied, and this is addition, so that is incorrect. For these two, I don't really know where the values come from. 4 to the power of 8 is incorrect. They took the 2 to the power of 8 and multiplied these two 2's together to get 4 to the power of 8, which, however, is incorrect and is a vastly different answer when 4 is multiplied by itself, since it is twice the size of 2. And over here, once again, they multiplied these two 2's together and then multiplied the 3 and the 5. This is incorrect. The base number would still need to be 2, and the 15 you would add these two instead of multiply. The second question asks us to look at the statement, look at the expression below. 3 times 3 times 3 times 3 times 3, 3 multiplied by itself 8 times, and then which answer choices are equivalent expressions. Select all that apply. So I counted up the number of times 3 is multiplied by itself, and it's 8 times, so that's equivalent to the expression 3 to the power of 8. So here you see the first expression was 3 to the power of 4 times 3 to the power of 4. And once again, in this previous one, I stated that in two exponents, if the bases are the same, the exponents may be added together when the two are multiplied. So x to the power of L times x to the power of j is equal to x to the power of L plus j. So in this scenario, the base would remain the same, and 4 plus 4 is 8, so that would be 3 to the power of 8, which is correct. Here, you can't really see it, I kind of blocked it. 3 to the power of 2 times 3 to the power of 6, that's the same scenario. 2 plus 6 is equal to 8. So 3 to the power of 8, which is what we're looking for, so that is correct. Here we have 3 to the power of 5, which is incorrect because 3 was multiplied by itself 8 times instead of 5. Here we have the 3 to the power of 8, which was we already proved was correct. And for e, we have 8 to the power of 3. Here they switched the two exponents. That is incorrect because 8 is such a large number. 8 multiplied by itself 3 times would be a vastly larger number. Identify each true statement. Select all that apply. And actually here it might not be vastly larger, but it would definitely not be the same as 3 times 8. Alright, identify each true statement. Select all that apply. So A is 6 to the power of 4 means 6 times 6 times 6 times 6. That's correct because the exponent simply means that the base needs to be multiplied by itself, however many times the exponent states. B is 6 times to the power of 4 means 6 times 4. That is incorrect. As we stated here, it would mean 6 times itself 4 times, not 6 times 4. C, 6 to the power of 4 means 6 plus 6 plus 6 plus 6. That's incorrect. This would need to be multiplied by itself instead of added. And D, 6 to the power of 4 means 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4. That's incorrect. The exponent may state how many times the base is multiplied by itself, but the exponent never appears in the actual expanded equation. Okay. And then number 4 is describe the role of the base and exponent in the exponential expression. So here's an example statement given. In an exponential expression, the base identifies the factor to be used, and the exponent is the number that tells how many times the factor will be repeated in an expanded form of the expression. In the expression 9 to the power of 3, 9 is the factor, and 3 is the number of times that 9 will be repeated in an expanded form of the exponential expression. So here they use the word factor. Previously I've been using the word base, but it's the same scenario that we've been going through, how the exponent dictates how many times the base or factor will be multiplied by itself. The next is investigation 2, understand rules of exponents, investigation 2. So same type of scenario. So the first one asks you to write each exponential expression in expanded form and then as a single power. So here we have 10 to the power of 4 times 10 to the power of 3. And here in expanded form you can see they multiplied 10 by itself 4 times and then multiplied that by 10 times itself 3 times. And then as we talked about previously, when the bases are the same, the two exponents can be added together to get them solution when these two are multiplied together. So 10 to the power of 4 times 10 to the power of 3 in this scenario, since the base remains the same, you would add 4 plus 3. So these two multiplied together would be 10 to the power of 7, because 4 plus 3 is 7. Here we had 2.4 to the power of 3 times 2.4 to the power of 3. So we had the 3, so we had 2.4 multiplied by itself 3 times, multiplied by 2.4 multiplied by itself 3 times. And then 3 plus 3 is 6, so we would get 2.4 to the power of 6. Here we have 3x squared times 3x to the power of 3. So we have 3x times 3x, which is the 3x squared, and then we have 3x times 3x times 3x to have the 3x cubed, and then we multiply those two together to get 3x times 3x times 3x times 3x times 3x. And then 2 plus 3 is 5, and you can also count them up in the expanded form to find out, and we get 3x to the power of 5. For 2, which of the following is equivalent to 3 squared times 3 squared times 3 squared? Select all that apply. So here we can look at it, and we have 3 times 3, which is the first 3 squared, times 3 times 3, which is the second 3 squared, times 3 times 3, which is the third 3 squared. If you count these up, that would be equal to 3 to the power of 6. Another way to look at it is 3 squared times 3 squared times 3 squared, and then add up all 3 of these squares, and 2 times 3 is equal to 6. so we'd also get 3 to the power of 6. So A is incorrect because the 6 does not multiply by the 3, it just dictates how many times 3 would be multiplied by itself. B is correct because, as you see here, it multiplies 3 times 3 6 times, which means that since the exponent 6 dictates that 3 needs to be multiplied by itself 6 times. C is correct because, as we showed over here, 3 squared times 3 squared times 3 squared is equal to 3 to the power of 6. This is incorrect. I'm not entirely sure. Oh, I see how they got it. They multiplied 2 times 2 times 2, but just because this is a multiplication sign doesn't mean you had to multiply these. You still add the exponents. The next question asks us to write an equivalent expression as a single power for each of the products of powers below. So the first one is 5 to the power of 3 times 5 to the power of 4. And we can use what we previously stated, how when the bases are the same, you can add the two exponents together to get their multiplied answer. So 3 plus 4 is equal to 7, so we get 5 to the power of 7. The next one is more of a rule, so we get 4 to the power of a times 4 to the power of b, which is equal to 4 to the power of a plus b, because you add the two exponents together. And then c is an exponential rule, so a to the power of c times a to the power of d. Because the two bases are the same, we can add the two exponents to get a to the power of c plus d. 4. Nia wrote these exponential expressions as a single power. A, 9 to the power of 4 times 9 to the power of 5 equals 9 to the power of 20. B, 7 to the power of 5 times 7 to the power of 2 equals 7 to the power of 10. And C, x to the power of 9 times x to the power of 3 equals x to the power of 27. Which error did Nia make? Nia used the sum of the exponents. B, Nia used the product of the exponents. And Nia used the quotients of the exponents. D, Nia used the difference of the exponents. B is correct because you can see here 4 times 5 is equal to 20. So she multiplied the exponents by each other. Once again, 5 times 2 is 10. 9 times 3 is 27. She multiplied the exponents instead of adding them. Write a rule to explain how to find the product of two exponential expressions with the same base. Use the rule to write x to the power of n times x to the power of n as a single power. So the example given was when two exponential expressions with the same base are multiplied, you keep the base and add the exponents. The sum of the exponents becomes the exponent for the base. The expression x to the power of m times x to the power of n would be written as x to the power of n plus n. The rule down here, whatever you wrote, is exactly translates into what we stated up here with a to the power of c plus d, just with different values, using x, m, and n, which are more common for rules. It's the same scenario that we've been using throughout the whole of the two problems by adding the exponents and keeping the base.